Hi there, welcome to this tutorial. Today we are exploring a dataset from the medical field. Our dataset includes 30 different features for each cell nucleus such as radius, texture, perimeter, area and more. These features are calculated in three ways: the mean, the standard error, the odds or largest value. We will be using a standard scalar to normalize our data, ensuring all features contribute equally to the model. Then, we will build a logistic regression model to make our predictions. By the end of this tutorial, you will have a solid understanding of how to pre-process medical data and build a simple yet effective machine learning model. So, let's get started. First, let's import some necessary libraries like NumPy, Pandas, Matplotlib and Seaborn. And to ignore warnings, we have to ignore warning libraries also. So let's import it. Now let's read the dataset. So before reading the dataset, first I have to import my dataset into here, Google Collaboratory. So for this, I need to go here and then select the data. Then open. My dataset is now on Google Collaboratory. Now let's read the data by using Pandas library. For this, I'm gonna save this dataset into df variable. So df is equal to pd.read underscore csv and then data. Now let's copy the path and paste it over here. Right. Okay. Now let's see the head. Okay. Execute it. Here is my data. Nice. So I have lots of columns. So for this, let's just see the shape of this dataset. Means how many rows and how many columns are present in this dataset, right? So df.shape. Okay, we have 569 rows and 33 columns, right? Okay, 33 columns. Let's see the columns. So df.columns. So these are the columns: ID, diagnosis, and many more, right? Okay, so let's see the info, right? So df.info. We can see that our dataset has 569 entries, and um, we have some null values present in unnamed column. So okay, let's just check by using the null method. So df dot is null dot sum. Yeah, we have a column which is unnamed and some null values are present in here. Okay, so for this I'm gonna drop this column because I don't think this column we can get some insight by using this unnamed column. So I'm gonna drop it and I'm gonna drop the ID columns also, right? So let's drop it. So df dot drop of what? Let's see the column name. Column is would be my unnamed. This unnamed 32 and ID. Yep, ID column. And my axis would be 1. If I write 0, then it would be the rows, and x is equal 1 means column. I'm just dropping the column. So I'm saving this into the df variable. Right. Okay, now let's see. Yeah. Okay, now let's check again. Okay, there is no ID column and is null, unnamed column, right? Okay, now let's convert the diagnosis column into numeric variable, because diagnosis has some categorical column. If I go to here, okay, right? So there is some categorical column. So yeah, let's convert it. So df dot diagnosis one if the value is equal m, right? Else 0 for value in this df dot diagnosis, right? Okay, now let's get executed. Okay, now let's just check the df dot hit, and I'm just gonna see three rows. Yeah, it has already converted into numerical values, right? Okay, now let's turn the target variable into categorical data, right? So for this, let's type df of what? Diagnosis. Diagnosis. Right. Now let's plot these values, right? So df of diagnosis is equal to, so df of diagnosis dot value counts, value underscore counts, value counts would be dot plot, right? I need to plot a kind would be bar. Yeah, and the title would be, let's just write in here, the title would be class distribution of benign and malignant, right? So class distribution of benign and malignant. Okay. Malignant, right? Now let's execute it. Yep, I got my plot, right? Okay, now let's prepare the model. For this, I'm gonna use logistic regression model. So before that, I need to split my data set into train and test for training and testing purpose. So let's just split the target variables. So my target is y would be df of diagnosis. This diagnosis would be my target variable, and I'm just gonna drop the target variable, which is diagnosis, and take all the other columns, right? So this would be x and this would be y. So let's get executed. Nice. Now let's just import the standard scalar from sklearn. So from sklearn dot preprocessing import standard scalar, right? Standard scalar, and I have initialized in variable to store the standard scalar, and I have fitted my scalar into scalar with my data set, which is x, and this would be not x scaled, this would be x scaled, right? X scaled. Now let's execute it. Yep. Okay, now let's just split the data set, right? So for this, I'm just gonna take 30% as test size and 70% for training size, right? So from sklearn dot model underscore selection import train test split, and I'm just gonna take x train x test and y train y test, right? And train test split x scaled. I am just passing my x scale data set and y target variable, sorry, y target data set, and test size would be 0.3, right? uh, and random state would be 42, right? Now let's get executed. Okay, perfect. Now import the logistic regression, right? So from sklearn import the logistic regression, and I'm just gonna not accuracy score, I just need to set the logistic regression. So yeah, my model would be logistic regression. I'm just setting as lr, and then lr dot fit x train y train, right? I'm just now let's execute it. Okay, I have successfully fit my model. Now let's just check the prediction. So y underscore pred would be lr dot predict and this would be my x test. So x underscore test. Now let's execute it. Okay, nice. Okay, so now let's see the accuracy, actually how my model is performing. So for this I'm calling the accuracy score from sklearn. So from sklearn dot matrix import accuracy score, and then I'm just setting a variable accuracy is equal to accuracy score, and here I'm just setting the y test and y pred, right? And print the accuracy. So print the accuracy, right? Okay, let's execute it. Yep, let's just um, take only the 2 decimal point, right? So for this, accuracy is equal to f, and this would be my dictionary, right? Now let's, okay, I have made a mistake. Not here, this would be in here, right? Okay, So these are my accuracy. This is my accuracy. This shows that my accuracy is 98.245%. Right. Okay. Now let's see the classification report. Right. So for this, I just need to type from sklearn dot matrix. I have to import the confusion matrix, and here I have to print the confusion matrix. Right. So sklearn dot matrix, import confusion matrix, and here's this would be my classification report. No, not confusion matrix. I have to write the classification report. Right. Okay, now let's execute it. Okay, here also I can see that my accuracy is 98%. So yeah, we have successfully built a logistic regression model to classify breast as benign or malignant using our dataset. Right. So this journey highlights how machine learning can assist in medical diagnosis, potentially saving lives by providing accurate predictions. So keep practicing and exploring more dataset to further sharpen your skill, right? Okay, so thank you for watching, and don't forget to like, share and subscribe for more tutorials. See you in next time.